A modern airliner cruises at around 35,000 feet. Mount Everest is 29,032 feet. So, the math looks simple. Planes fly higher than the tallest mountain on Earth. So why don't commercial jets just fly straight over Everest? On a flat map, it seems obvious. Asia to Europe, Europe to Southeast Asia. Just draw the line, climb over the mountain, save time, save fuel, and let the passengers enjoy the most expensive window view on the planet. But aviation is full of rules written by engineers, regulators, and occasionally, mountains that refuse to negotiate. Look closer at real flight routes. Most commercial airliners avoid flying directly over Everest and the highest central Himalayas. They go around. They follow carefully planned corridors. They leave themselves a way out, because the problem is not climbing over Everest. The problem is what happens when the airplane suddenly needs to stop being heroic to understand why Everest still makes flight planners nervous. We need to go back to 1933. This was aviation in its "what could possibly go wrong" era. A British expedition set out to do something no one had done before: fly over the summit of Mount Everest. The mission was led by Lord Clydesdale, with David McIntyre flying the second aircraft. And they were not flying pressurized jets with heated cabins, weather radar, satellite navigation, and 300 passengers complaining about the Wi-Fi. They were flying two modified Westland biplanes, a Westland PV-3 and a Westland PV-6, the prototype of what would become the Westland Wallace. They had open cockpits, oxygen, masks, heated suits, cameras, very little margin, and no parachutes, because apparently the mountain was not already dramatic enough. As the aircraft climbed toward Everest, the air grew brutally cold and painfully thin. Their oxygen systems were essential but fragile. One crew member briefly lost consciousness from hypoxia after an oxygen line was damaged. McIntyre's oxygen mask strap reportedly broke, forcing him to hold it in place while flying. Then the mountain fought back. Downdrafts slammed the aircraft and cost them altitude. The planes were pushed down by invisible rivers of air spilling over the peaks. For a terrifying moment, the question was not whether they could fly over Everest. It was whether Everest would let them. They made it. Barely. The aircraft passed over the summit and captured some of the first aerial images of the roof of the world. It was a triumph of courage, engineering, and honestly, a level of risk tolerance that modern airlines try very hard not to put in a brochure. But the lesson was not: Everest is easy. The lesson was: Everest can be crossed, but only if almost everything goes right. And commercial aviation is built around a very different idea. What if something goes wrong? Here is the core reason airliners avoid direct routes over Everest and the highest Himalayas. It is not altitude, it is escape. Modern airliners are pressurized. At cruising altitude, the air outside is far too thin for passengers to breathe normally. Inside the cabin, the pressure is kept much lower than sea level, but still survivable, roughly like being at a high mountain town, not floating near the edge of space. But if the aircraft loses cabin pressure, everything changes. A cracked window, a seal failure, structural damage, even a severe systems problem. If the cabin depressurizes, pilots must get the aircraft down to a safer breathing altitude as quickly as the situation allows. In normal terrain, that usually means descending toward 10,000 feet, where most people can breathe without supplemental oxygen. But over the Himalayas, the ground itself may be higher than that. The Tibetan Plateau averages over 13,000 feet. Many Himalayan peaks rise above 26,000 feet. Everest rises to 29,032 feet. So if a plane loses pressure here, just descend becomes a much uglier sentence. You cannot simply dive to 10,000 feet if the terrain below you is a wall of rock and ice. Over high mountains, airlines must plan escape routes. These routes allow an aircraft to descend to a safer altitude while still clearing terrain and while passenger oxygen supplies last. In other words, the route must answer the most important question in aviation. If this goes bad, where do we go? Over much of the central Himalayas, that answer is uncomfortable. This is why route planning over high terrain is so strict. It is not enough for a plane to be able to fly over a mountain on a good day. It must be able to survive a bad day. And Everest is not famous for giving refunds on bad decisions. Depressurization is only one problem. There is also the engine failure problem. Modern twin-engine jets are incredibly reliable, but flight planning still assumes that one engine can fail. If that happens, the aircraft may not be able to hold the same cruising altitude. It follows what pilots call a drift-down profile, gradually descending to an altitude it can maintain on one engine. Over flat land, that is manageable. Over the Himalayas, gradually descending can become a geometry problem with lethal consequences. The airplane must still clear the terrain. It must still have enough performance, and it must still be able to reach a suitable diversion airport. That last part is a major issue. The Himalayas are remote. The weather changes fast. Many airports in the region are small, high, difficult, or surrounded by terrain that is very impolite to large aircraft. Some of these runways are famous for a reason. Paro in Bhutan sits in a narrow valley surrounded by high mountains. Lukla in Nepal is legendary among pilots and passengers with strong stomachs. These airports are not the same thing as easy emergency alternates for a fully loaded long-haul jet. So again, the issue is not whether an aircraft can cross the map. The issue is whether it has a safe way out when the map starts fighting back, even if the engines are fine. And the cabin stays pressurized. The air above the Himalayas can still be a nightmare. Mountains do not just sit there looking inspirational. They disturb the atmosphere. When strong winds hit a massive mountain range, the air is forced upward, then down, then upward again. This can create mountain waves, invisible currents that extend far above the peaks. A plane can be cruising in clear sky and still hit severe turbulence. No clouds, no warning. Just the atmosphere deciding to throw furniture. The jet stream can also be extremely strong near this region. High-altitude winds shift, accelerate, and interact with the terrain in complex ways. That does not mean every flight near the Himalayas is dangerous. Airlines do fly near and over parts of high terrain, using approved routes, weather planning, oxygen rules, and escape procedures, but flying directly over the highest, most remote section around Everest adds risk without enough reward. And in aviation, risk that does not pay for itself usually gets deleted from the route. There are famous stories of aircraft losing multiple engines in flight. One of the best known is British Airways Flight 9 in 1982. A Boeing 747 flew into volcanic ash from Mount Galunggung near Indonesia. All 4 engines failed in quick succession, and the aircraft became, briefly, the world's least relaxing glider. The crew eventually restarted the engines and landed safely in Jakarta. But that case was volcanic ash, not Everest, and not ice crystals. The reason it matters here is the lesson. Even extremely rare failures become survivable only when crews have altitude, time, and somewhere to go. Over the highest Himalayas, those margins shrink. Aviation safety is not built on probably fine. It is built on what if it is not? So do any planes fly near Everest? Yes. Nepal has sightseeing flights often marketed as Everest experience flights. Small aircraft take passengers from Kathmandu toward the mountain region, usually in carefully chosen weather, then return within about an hour. But these are not the same as long-haul airliners crossing the highest Himalayas with hundreds of passengers and intercontinental fuel loads. They are shorter, lighter, more specialized flights, operating under conditions where the whole point is to see the mountains, not to use them as a shortcut. Military aircraft, research missions, and specialized high-altitude platforms may also operate in extreme environments. But again, these are exceptions. Different aircraft, different missions, different risk calculations. For everyday commercial aviation, the safer answer is usually simple. Go around. So the next time you look at a map and wonder why a flight route bends around the Himalayas, remember this. The mountain is not too high for the airplane. It is too unforgiving for the emergency. A jet can fly higher than Everest. But if the cabin loses pressure, if an engine fails, if the winds turn violent, if the aircraft needs a runway fast, the highest mountains on Earth leave very little room for improvisation. The pilots of 1933 proved that Everest could be crossed. Modern aviation learned a different lesson. Just because you can fly over something does not mean you should. Some boundaries are not marked by fences, borders, or laws. Some are written in wind, oxygen, terrain, and consequence. And Everest is one of them. If you like hidden rules, strange maps, and the systems quietly shaping our world, subscribe to Global Facts. And tell us in the comments, would you take an Everest sightseeing flight? Or would you rather admire the mountain from a very safe distance?